Huh? I was there. Okay, you guys will need a blank piece of paper, and I need you to turn in the book assignment from yesterday. So, if you did not do that in Google Classroom already, please find that, make sure your name's on that, and have it to me by the end of the minute of silence, please.
Friday, September 13th, 2024. Will you please join me for a minute of silence?
Will you grab one?
Thank you very much. Will you please stand and stand for the pledge? Allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, last call. Any other homeworks? Okay, so today I need to introduce a couple new things to you. I need to show you one real-world application of derivatives on assignment 18. Also, I'm not sure if I numbered these. You might double check. 18 is the one that says something about position, velocity, and acceleration, and speed. And of the derivative stuff we talked about yesterday, other than a few memorization ones, we only really did the power rule. Power rule is fine for adding and subtracting within derivatives, but it's not okay within multiplying and dividing. We have to have special formulas for those, and those are called product and quotient rules. So I need to show you what those are, do a few examples of those, and then we've got an extremely long book assignment, but we will only get part way through that. You won't have to have that finished by next class. We'll do what we can do in class, and then I'll ask you to do a couple more for homework. To force you to think about it the second time before I see you again. Okay, so I know this kind of came up in one of my classes. I don't remember if it was y'all, but I tried to address it on one of the graphs we saw on the handout yesterday. Because one of the graphs we looked at was a position graph. Now for position, we typically use S of t or X of t, just depends on the question. So a position equation you would use if you want to know where something is at a particular time. You want to know where it's at time 2, you plug 2 in for t. You want to know the time or where it's at 10 seconds, you plug in 10 seconds for t. Okay, but then we have this thing called velocity, which velocity is very similar to speed. It's not exactly the same thing as speed. We'll talk about that down here. But if you think about how something is changing at an instant of a position graph, that actually ends up being the velocity. So sometimes for velocity we call it v of t for velocity, but it's also found by taking the derivative of position. If you take all of the slope values of a position graph and take those values and make a new graph, you end up with a velocity graph. Okay, and then it turns out if you take the derivative of velocity, so if you're looking at a velocity graph and you measure all of its slopes, all of its instantaneous rates of change. That is going to be measuring acceleration. So sometimes for acceleration, we're going to say it's the derivative of velocity, and that means it's also the second derivative of position. Now this is a common thing that's going to come up all year long, even second semester. Just that in first semester we do derivatives, so we tend to work this way. If you have position, you want velocity, take the derivative. You have velocity, you want acceleration, take the derivative. But next semester when we do integration, sometimes we can start with acceleration, integrate it back to velocity, and then integrate it again back to position. So this relationship is very important. Okay, I think when we talked about this yesterday, I think it came up in y'all's class, but I let y'all go ahead and say that the slopes of the position graph represented speed, and it's not exactly speed, because speed is always positive. Velocity can be negative or positive. If velocity is positive, that means that something's moving up or to the right, just depending on the context of the question, it's up or right. Whereas velocity, if it's negative, that tells us it's going down or left that fast. Again, the down or left just depends on the question, the context of the question. Whereas speed doesn't matter. If I ask you what was your top speed in the car today on your way to school, you're not going to tell me negative 55 miles per hour. No one's interested in the direction that you went. They just care about how fast you were going. So when we talk about speed down here, speed is the absolute value of velocity. Okay, so just a couple real quick examples here, just throwing in some fake numbers into a position equation. And we do need to also discuss units. So let's go ahead and it says S is supposed to be in feet. And let's also just say that T is in seconds. That way we can do the units on each of these. So if you would like to know the position at 1 second, you would plug 1 into the position equation. And it looks like after 1 second, he is at position 7 feet. If you want to know the velocity at 1 second, you would need to plug 1 into the velocity. But the velocity equation may not be given to you. So you would need to say, well, if I've got position, taking the derivative of position gives me velocity, and then you just plug 1 into that, and you get -2. Now, velocity, like a speed, it's got to be a distance per amount of time. So in this case, the distance we're talking about is feet, and the times we're talking about are seconds. So velocity would be feet per second. Again, it's like a speed, so it's how much distance are you doing per how much time. Okay, whereas speed is very similar to velocity. The speed at 1 second is the same thing as the absolute value of velocity at 1 second. It's basically measuring the same thing, it just doesn't care about direction, so it doesn't care about positive or negative. And then in addition to these, or in place of those, if the question wanted to know what's the acceleration at time 1, you're just going to plug 1 into the acceleration function. If you don't have the acceleration function, you just need to keep going with your derivatives. We took the derivative of position to get velocity, and you can take the derivative of velocity to get acceleration. So since there's no t's here, it means acceleration is always 2. What kind of units do you think acceleration is going to have?
Feet per second squared.
Very good. Feet per second squared. So it's got an additional time unit. Now I will warn you before you see these on a quiz, but just so you guys know, the units do get scored in our course because they get scored on our AP exam. A lot of times on free response questions, there might be a point or 2 that'll say they only get this point if they did all the units correct. So distance / positions are going to be linear. Feet to the first, inches to the first, miles to the first. Velocity is going to be a distance per time. So this one was just feet and seconds because of the concept, or this, what it was asking about in this question. Speed is basically the same thing, it just doesn't care about positive or negative, it's always positive. And then acceleration is a unit of distance per time squared. So the sooner you practice those, the better. So again, assuming you got the position equation, assuming you can take basic derivatives like power rule, knowing the derivative of a constant is 0, that's all I did to get those. Then you want to know the position at 3, you're just going to plug 3 into the position equation. But I'm doing the same things now, I'm just plugging in a different number. So it looks like at 1 second he was at 7 feet, but also at 3 seconds he was at 7 feet. You want to know the velocity at 3 seconds, you need to plug 3 into the velocity and you get 2 feet per second. So at time 3 seconds, is this thing moving to the right or to the left? How do you know that? Right. If velocity is positive, it's either going right or up. At 1 second, was it going right or left? Left, because if velocity is negative, it's going left or down, depending on the context of the question. Velocity and speed are basically the same thing, but except speed is always the absolute value of velocity. So if you want to know the speed at time 3, take the absolute value of the velocity at times 3. Still 2 feet per second. And acceleration, just plug 3 into the acceleration function. Again, this one doesn't have any t's in it, so it's saying that the acceleration is always 2, based on the units, feet per second squared. So the only calculus thing you really need, and you might want to add to the notes here at the top, I feel like this is a good visual description of that, but if you need to add words to it or something, then please do. Derivative of position gives you velocity. The derivative of velocity gives you acceleration. The second derivative of position gives you acceleration. So I'll pause for just a second if you want to add to that. I know it's very intuitive for some of you. Those of you that are in physics or had physics, it's pretty intuitive. But it's maybe not for the rest of you. Okay, next up on the back of this page, I just want to look at a couple question types that in the past students have struggled with. So I felt like maybe if we talked about them early, it would be one additional time that you had seen it, and that might help you. But this used to be a question that we used to put on one of our first tests, and this has to be a calculator question. So if I have not told you this yet, I know it's on our website, but half of your AP exam will allow a calculator, half will not allow a calculator. Half your points on your AP exam come from calculator, half come from no calculator. But there's a lot of calculator questions that don't need a calculator. So I think you get like 15 calculator multiple choice questions, but only 3 or 4 will actually need a calculator. Okay, so my question to you is, if I want to know the acceleration at 1.5, how am I supposed to find that? Okay, acceleration is the same as the derivative of velocity. So the acceleration at 1.5 is the same as the derivative of velocity at 1.5. Now again, you don't know how to take the derivative of this yet. You'll be pretty close after I go over the next handout, because that's almost something called product rule, but it's not. There's actually one more piece to it. So what I'm wanting you to get out of this question is the calculator work. You need to know that sometimes it's appropriate to use your calculator. So if you have a calculator, I guess you can go ahead and get it out, but if you don't have one in front of you, it's fine. The reason why this is important to show you early and often is on the calculator portion of your AP exam, which means in our class on an assessment or two, I'm going to say you can use a calculator on these questions, and you're not going to need it on some questions. But then there could be a question like this where I let you use a calculator, and even if you knew how to take the derivative of that, which you won't, trying to think. No, I guess you'll know how to do the derivative of that by the end of this unit. But even if you, once you do know how to do it by hand, if you were allowed a calculator, you should let the calculator do it for you. So one place to find what I'm asking you to do here is by doing alpha window. So if you don't have a calculator in front of you right now, you might want to write the button steps down on your paper. Alpha window should pull up this menu. Now, if you have your own calculator and it's a TI-83 or older, you're not going to get this menu. Also, if you have a TI-84 and it's an older one and no one's ever updated it, then you're not going to get this menu. But if that's the case, you're welcome to just borrow one of mine when you need it. For our class, for your AP exam, they expect you to know about these two and use them sometimes. Because sometimes they're going to ask you to take the derivative of something that you literally cannot take by hand. They expect you to do it in the calculator. So option 3 is referring to derivatives. Option 4 is referring to integration. Again, integration second semester. But if you were to pick option 3, what you have to do is define the variable. So I'm taking the derivative with respect to x, which just means there's a bunch of x stuff here. Or you could do t. And then what was that equation? It was like t squared.
Sine of x squared.
Okay.
Or t
This-
sine of t squared.
Okay, so like this, but t's. Okay, so since I said x, it's the same thing. But you could do t here if you do t here and t here. Okay, however, your calculator has not been programmed to do derivatives for you. College Board considers that to be too powerful, so you couldn't use a calculator in this type of calculator in the AP exam. But it can take the derivative at a specific point. And so we want to know the derivative at 1.5. And assuming you're in radians, because everything in calculus is radians, we don't bounce back and forth like pre-calculus, there's your answer. Negative 2.049. Negative 2.049. Now, if you type that in and got a wildly different answer, you're probably in degree mode. It's got to be in radians, especially if there's a trig function. And then again, the units would be something like a distance. I don't know, I'll just make up a distance, like miles per a time. So let's say hours. And then because it's acceleration, it would be squared. So our book assignment, oh, did I show you that yesterday? The derivative with the calculator? I did? Okay, good, good. Sorry, I just can't remember. This is where I had it in the notes to make sure to talk about it. Your calculator can do derivatives, but it can only do derivatives at a specific point. It can't do in general in terms of x or in terms of t. So anytime you have a calculator, consider doing that, especially if it makes sense. All right, and then often, this is what they like to try to test you on, so this is a little bit different than you've seen in the past. This is not a position graph, this is a velocity graph, velocity time graph. So just hypothetically, so we have units here. Let's say that time is in seconds again, and velocity might be, I don't know, let's do feet per second. Velocity is the speed. Okay, so I've already told you how to approach this first part. So let's see if anyone can guess the correct answer. Using this graph is represents a particle, so some particle is just moving back and forth. It's moving left, right, or up and down, but this one's about right and left. So when do you think this guy is going to the right?
From 0 to 10 seconds and from 40 to 55 seconds.
Nope.
0 to 30.
Why 0 to 30?
Because it's velocity, and the whole time the velocity is positive until it gets to 30.
Very good. So velocity is positive. When velocity is positive, that would be like your justification. 0 to 30. It's moving to the right. How did you know velocity was positive from 0 to 30?
Because it's above 0.
Right, it's above the x-axis. Values above the x-axis are positive. Okay, how or when is it going to the left?
30 to 60.
Good. So that could be a question on an FRQ, probably will be. And then it'll say justify. So how did you know it was going to the left from 30 to 60?
It's not 30 to 60, it's 30 to 60, 55.
Oh, good catch. It's 30 to 55. That would get you a lost point there. You gotta be careful. How do you know it's going to the left during that time?
It's negative or below 0.
Okay, what is negative?
Velocity.
Velocity. Don't say it's below the x-axis, because as soon as y'all start using vague terms like it, I can't assume what it is. I have to assume that you're saying the right thing on the test. The velocity is negative. Or I guess you could say the velocity graph, where the velocity graph is below the x-axis. Okay, is there any times where this particle would be at rest, so not moving at all?
30.
0, 30, and 55.
Very good. At 0, 30, and 55. At 0 seconds, 30 seconds, and 55 seconds. Okay, and how did you know it was at rest at those times?
Because it's equal to 0.
What is it?
Or velocity is equal to 0.
Very good. So when velocity is 0, it's not moving. When velocity is positive, it's going right or up, depending on the context of the question. When velocity is negative, it's moving left or down. So the only thing about the graph is above the x-axis is when it's positive, below the x-axis is when it's negative, and on the x-axis is when it's 0. So again, it's like this could easily be 3-4 points on an FRQ, and this is all the justification. Easy justification. You don't need like a paragraph trying to defend your answer. Velocity is positive, it's moving to the right. Velocity is negative, it's moving to the left. Velocity is 0, it's not moving. Okay. Now I guess I should say up here for the unit, since it did say include units. Technically this was just velocity, and I already said velocity was feet per second. This question was about velocity, so it was feet per second also. Okay, now, actually I guess before I say that, do yourself a favor and don't oversimplify this. Don't just say, well, I know it's going to the right when it's above the x-axis, and it's going to the left below the x-axis. I'll just memorize it that way. That's fine if you memorize it that way, as long as you put an asterisk there that you're talking about a velocity graph. Sometimes we're going to be looking at functions though, and all of a sudden that doesn't apply anymore. Sometimes we're going to be looking at acceleration graphs, and all of a sudden that doesn't apply anymore. Think of it like this. Positive, negative, or 0. Right, left, or at rest. Okay, now, before we can move on from this one, I want to know the acceleration of this particle for each little interval that it's changing. How am I supposed to know anything about acceleration when they told me something about velocity?
Slow velocity.
Okay, so how does acceleration and velocity compare?
Acceleration's the derivative.
Okay, so if I could take the derivative of velocity, I get information about acceleration. I heard at least one person say even beyond that. How am I supposed to know about the derivative of velocity? Derivative means slope. So the slope of velocity tells you about acceleration, because slope and derivative mean the same thing. That's why I keep bugging you about that. You need to, sometimes when you want to know something about derivatives, you have to think about slope. And sometimes when you want to know something about slope, you have to think about derivatives. But we can answer this because during this time it has the same slope. We can do rise over run, 6 feet per second squared. What would the acceleration be during this time? 0 feet per second squared. This big piece has the same slope all the time, which means it's going to have the same acceleration all the time.
Negative.
Negative 4 feet per second squared. That's what I got. Again, I'm just counting rise over run. And then finally, all of this time has the same slope, so it's going to have the same derivative, so it's going to have the same acceleration. It's going up 40 to go right 15.
2.5.
I don't know. I have to do this one step at a time. I can divide both these by 5,
No, that's not it.
so 8/3. Is that right? Yeah, what you got?
Is acceleration a vector, or would it change, like, if you're accelerating in a negative direction, would that still be positive acceleration?
You can accelerate in the negative direction. That is true. Is that your question?
Yeah. But I'm saying, would you represent that as a positive value of acceleration or a negative value of acceleration?
The same as slope. If the slope's positive, acceleration's positive. If the slope's negative, acceleration's negative. Now, I think maybe what you're kind of getting to, and this is about 5 months too early, but we will be asking questions about, is something speeding up or slowing down? And so when velocity is positive, we know it's going to the right or up. When velocity is negative, it's going left or up. And then when acceleration is positive, it means it's speeding up to the right. So when they're both positive, we can say that the particle is speeding up because you're moving to the right and you're moving to the right quicker. But sometimes if you're moving to the left and your acceleration is negative, then you're moving to the left quicker. This is also speeding up. So when we get to this in about 5 months, I will simplify it and say the signs need to be the same. If they're both positive, then it's speeding up to the right. If they're both negative, it's speeding up to the left. And if they have different signs, then they're slowing down. You don't have to know that today, though. Okay. Let's slide over to the other handout. So again, yesterday we talked about some of the ones you need to start memorizing. The derivative of a constant is 0. Talked about the derivative of a constant is 0. We talked about the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of natural log of x is 1 over x. The derivative of e to the x is e to the x. But within all of that, we basically just did one of the rules, which is power rule. So with this handout, we're going to look at product and quotient rules. So the name is trying to give you a hint about when you should use these. Product means,
Multiplication.
so if you're trying to multiply something times something, like question 1, or question 2, I've got something times something, you can use what's called the product rule. And again, it's basically a formula that we will memorize, or memorize the pattern. And then quotient rule, what does quotient mean?
Division. It's the result of division.
Good. So if you're wanting to take the derivative of something divided by something, like question 3, you have to use the quotient rule. Now, the main thing here, before I even tell you what these are, sometimes there'll be a couple students that do this for a week or so, and they're super confused until they get it straightened out. You may not just take the power rule of this, and then the power rule of this, and then slap a multiplication sign in between them. If it worked that nicely, I would have just told you that on the first day with the add and subtract. If you've got something times something, if one of those is a constant, that's not the case. But if it's two different things that have a derivative, you have to use the product rule. There's no way around it. So this is what the product rule says, and it looks pretty complicated, but it's actually a pretty straightforward pattern. Basically says you're going to call the first thing f of x and the second thing g of x, and I'm going to color coordinate this for you to help you see these. And if you want to take the derivative of these, which is what this notation out to the left is saying, it says take the derivative of the first one times the second part left alone plus, and then you're going to do it the other way, the derivative of the second part times the first part left alone. So if I wanted to go from y to y prime, I'm going to take the derivative of the square root of x. Now I'm going to go pretty quickly on the power rule stuff. I know that you're not quite up to speed at this speed, but just for focus sake. So the derivative of the square root of x, I would bring the power down and lower the power by 1 and get that, times the second part left alone, and then plus, and now we're going to do it the other order. I'm going to take the derivative of the second part, the derivative of e to the x is just e to the x, times the first part left alone. All of that represents the derivative. You take the derivative of each one once, plus the regular function left alone. Okay?
So is that it?
That's it. Now, the thing that's going to be kind of frustrating about the book assignment is technically this is the derivative, but when we move over to the book assignment after this handout, we will need to simplify these sometimes. We'll simplify until we get it to match up the back of the book. And sometimes the simplifying is a pain, but it's necessary because when you see this type of question on your AP exam or on our exams, if it's multiple choice, it's going to have some simplifying done to it before. But for our notes, we're not worried about that. Okay, so if I want to go from f to f prime in question 2, notice I'm recognizing I've got something times something, x squared times square root of x minus 1. So take the derivative of the first part, the second part left alone, plus, and then just do it in the other order. Now leave the first part alone and take the derivative of the second part. Again, I know I'm doing the power rule quickly there, so just trust me that the derivative of x cubed is 3x squared and the derivative of square root of x is 1 over 2 square root of x. And that's it, other than maybe having to simplify it. So once you practice the product rule 10, 20 times, you'll learn this pattern and you will should be fine with that. Now, I guess my deeper question is, does it matter what order you do these in?
No, as long as they're connected terms.
Okay, how do you know that the order doesn't matter?
Or, well, I just meant like, you can't pair the f prime x with the fx, but you can do g prime x and then f of x, or you could do fx and then g prime x.
You're correct, but how come?
Multiplication.
I'm more thinking about this sign.
Oh.
If
yeah,
you wanted to do this stuff first and then add that stuff, you can, and if you'd rather do that stuff plus this stuff, you can. Because the order of adding doesn't matter. 5 plus 3 is always the same thing as 3 plus 5. I'm only pointing that out to you because our other rule we need to know, the quotient rule. So, quotient is when you've got something divided by something. They're calling the numerator stuff f of x, the denominator stuff g of x. The order of this one matters because it's got a subtract sign, so be careful with that. You can't do these parts in any order you want to. It says take the derivative of the numerator, which would be e to the x. The derivative of e to the x is e to the x, times the denominator left alone, minus, now I want the derivative of the denominator, and what is the derivative of the denominator? Okay, times the numerator left alone, e to the x, And then the part that students sometimes forget, so make good habits here, don't be lazy. The whole thing is over sine squared. Sometimes people try not to write that until the very end, but then they forget about it. So technically that is its derivative. You don't have to write this part down for your notes, but what's probably going to happen when we practice it in the book assignment is they'd probably at least factor out the GCF or something. They would probably factor out that e to the x, something like that, but they're equivalent. So. Okay, anything that jumps out at you about the quotient rule? Again, obviously it takes some practice before you know it, but derivative of numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone all over the denominator squared. You just keep reinforcing that pattern, then if you can do power rule and you can do the ones you have to memorize, this is just asking you to kind of pool those together for a single question. Okay, so I do want to show you the derivative of trig functions before we move forward here. So we've already talked about these two yesterday. Those are the ones that get used all the time. You don't have to memorize these just yet, but you will have to memorize them before we get to our next quiz. The derivative of tangent, the derivative of secant, the derivative of cosecant, and the derivative of cotangent. One thing I always point out that I think helps just a tiny bit is notice anytime you take the derivative of something that starts with a c, like the derivative of cosine, the derivative of cosecant, the derivative of cotangent, what is true about all of those derivatives? They're all negative. So anytime you're taking the derivative of a trig function that starts with c, at least you know it should be negative. And if you're taking the derivative of a trig function that doesn't start with c, notice they all start off positive. So that helps a little bit, I guess, but you will have to memorize those at some point. Okay, what I would like to do is we want to practice a few of these on your notes page before we slide over to the book. So how I would do, I'm going to do the first two with you here, and then I'll have you try the other two as guided practice. So I would like to take the derivative of this mess. So to go from g to its derivative would be g prime. So my first term is this. Now remember, if it's a constant out front, like 3, you're welcome to just put the 3 out front and then do the rest of the calculus. It's going to make the derivative 3 times bigger. And you'll memorize, you see it at the top of your page, but you'll memorize the derivative of secant x is secant x tangent x. And then that part's done. Likewise over here, you already did some questions like this yesterday. The derivative of negative 10 cosine x would be positive 10 sine x. The reason why you don't have to do product rule here is because this is a constant. This is the constant multiple thing. Although I guess you could, it just would be kind of silly. Okay, and then I look at question 5, and this matches up with one I memorized. It's going to be 4 times the derivative of cosecant, which is cosecant x cotangent x. Again, that one you'll memorize eventually. And then when I want you to take the derivative of this, what I'm afraid is going to happen is you're going to say, I've got 5 times the derivative of e to the x times the derivative of sine x, which is this. That is not how that works out. If we can just take the derivative of each one separately and slap a multiplication symbol in between them, then there's no need for the product rule. That does not work. You have to realize this is 5 times, I'm just going to deal with the 5 at the end, this is e to the x times sine of x. It's something times something. Your only option is product rule. So you'll need to take the derivative of the first part times the second part left alone, plus then leave the first part alone times the derivative of the second part. You have to do the product rule because you're trying to do the derivative of something times something. The only time you don't have to do that if it's a constant, like the 4 or the 5. And again, usually you need to simplify some. I would probably normally at least factor out the e to the x, but we'll get plenty of practice on that on the book assignment. Okay, so copy that one down, please, and then I would like you to put some thought into question 6 for a second.
Can you go up to 4? I didn't finish my copying down the answer. Okay, that's 10.
Got it?
No, not yet. I didn't know what the 10 part was for a second.
I just used the derivative at the top of the page.
There you go.
Okay, so just try question 6, please. Just do whatever you think. Okay, so I don't think I gave you enough time, but I should have given you enough time to see what you thought the process should be. So right here, you might want to rewrite this before you do any calculus. Notice I'm not saying this is the derivative yet, but what you would have done yesterday is pulled this up to the numerator, or that's what you should have done. So I would recommend that you do that before you do any calculus. This is still just a power rule. You can bring the power down, lower the power by 1, and then move it to the other side of the fraction. Minus, now here's the part that I really wanted to see. Did you realize that you had to do the product rule here? You've got w squared times tangent w. Something times something has to be product rule. So if you realize that, you should have taken the derivative of w squared with tangent w left alone, and then plus w squared left alone times the derivative of tangent, which you probably had to look at the top of your page for. That is secant squared. So the first term was just undoing the power rule, but you had to rewrite it first. The second term, your only option was product rule. So make corrections there, please, and then try question 7. Okay, I'm cutting you off already. Again, I mainly just wanted you to see if you recognize which path you should be heading on. You're going to get lots of practice on actually trying to finish these and simplify these. So again, you may not just take the derivative of the numerator, then take the derivative of the denominator, and then slap a division sign in between them. I wish that was the case. We would not need quotient rule if that's the case. This one has to be quotient rule. You've got something divided by something. So, quotient rule says I should take the derivative of which one of these first? Okay, the numerator. times the denominator left alone. Okay, and then is it plus or minus? Minus. Okay, and then I'm going to do the opposite of what I did here. So this time I'm going to leave the cosine t alone, but take the derivative of 3 minus 2 sine t, which would be negative 2 cosine t. Derivative of 3 is 0, so I don't need a 0 minus. And then it all goes over the denominator squared. Now again, there's going to be times where simplifying it down to try to be able to match it up with the multiple choice question is going to be a pain. But technically, if you get that far, you are applying the quotient rule correctly. So anything that jumps out at you about that example? Okay, I know that was a lot, but on your blank piece of paper, if you go ahead and copy the assignment down, I know it's a lot of information, but there's no way around just kind of showing you what it is before we get started here. So copy that full assignment down on the blank piece of paper, please. And we are going to look at some of this together. And again, I'm going to ask you to do a couple for homework, past where we get as a group. But you will not need to get anywhere near finished with this, so don't be intimidated by the size of the assignment. Like yesterday, I will need these book handouts back if you just put them back on the table at the end of class. But go ahead, copy the assignment down, and then try to start with question 3. I'm going to give you all a few minutes to do that, and I'm going to finish putting the rest of these homework papers in and try to get them back to you today. The other thing is, I think I mentioned this yesterday, but there's not a million different ways your AP exam will expect you to be able to take derivatives by hand. They expect you to memorize some. You've probably seen about half of the ones you're expected to memorize already. You certainly are expected to be able to use power rule. You'll be expected to use product and quotient rules. You're expected to take derivatives in your calculator, which I have showed you that today. And then honestly, the only other derivative they expect you to do by hand is something called chain rule. So even though this seems like a lot of information today, you almost have seen all of the stuff they expect you to do by hand. So hopefully that offers some encouragement. Also, like I did yesterday, you've got to flip a couple of pages, but these book handouts do have the solutions attached at the end too. So, as you work question 3, that's an odd question. If you want to check your answer on the back pages and you got that correct, then feel free to move on. And if it looks like maybe they simplified the answer some, make sure that you simplify the answer to get to the same point. And if you're not sure, then make sure you're paying attention when I go over it in a few minutes.
So how much are we gonna get through today on this sheet?
I don't know. It just depends on how much time we've got. We'll figure it out before the end of class.
I mean, just like how much time is left in class.
Oh, we've got 40 minutes. Is that on you? There you go.
I'll just put the grade in right now. Okay. So I am going to look at question 3 now. So it looks like the answer to question 3, they came up with 1 minus 5t squared over 2 square roots of t as an answer. So there's a good chance you may have done the derivative correctly, and then maybe you didn't know how to simplify it to get to that. And again, that's what I was trying to say. That's what I was trying to say can be a little bit frustrating about some of these questions. But if you did not get that as an answer, I will go over it. If you are comfortable with that as an answer, then just go ahead and keep on going and do the next question. So question 3 wants me to find the derivative of h of t, and h of t is the square root of t times 1 minus t squared. Now, just so you guys know, the directions say use the product rule, so I'm going to use the product rule. But honestly, if this was just totally up to me, I would probably just distribute this and then take the derivative of both terms using the power rule. Just because power rule is so much quicker and easier to me than the others. But it specifically asked me to use the product rule, so I will use the product rule. So you need the derivative of square root of t. Now if you need to go out to the side and say this is what the square root of t is, so the derivative would look like this, which becomes this. Feel free to do that out to the side as needed. Times this left alone, plus, now I'll leave this one alone, times the derivative of this one, which would be minus 2t. So the most important thing is that you got to that point. Because if you didn't get to that point, you're either not doing the power rule correctly or you're not applying the product rule correctly. And again, you've got your notes in front of you, so that should be pretty hard to do. Are you guys okay with this thus far? Okay, so let's say you do this on the test, you get this as an answer, you look at your choices, this is the correct choice, this looks nothing like this. So at first you might double check your derivative, you might double check you did the product rule correctly, but then ultimately you got to think of a way to simplify this and make it look like this. So what could I maybe do with this mess of stuff? What? Okay, we could distribute. What'd you say?
Conjugates or no?
I know, I don't think we'll need conjugates. But y'all are thinking in the right area. It's something algebra related. How many terms do I have down here?
4, 2.
Oh, well, I'm thinking of this as one big term. I'm not thinking of this distributed. You see how we've got like 2 big terms here? And this is one big term? We got to think of some way to combine these together. Okay, what you need for this question is common denominators. This one has this as a denominator. This one has a 1 as a denominator. Notice how they have one big fraction with this as a denominator. So it looks like they multiplied the top and bottom by this to get common denominators, so that you can write it as one big fraction. Then I'll go ahead and distribute here, and I'll multiply this mess of stuff together. I've got a negative 2 times 2, which would be -4. I've got a square root of t times the square root of t, which would be what? Times another t, which would be t squared. And now do you see how they got to 1 take away 5t squared over that? They just combine these two like terms. -1t squared minus 4t squared is minus 5t squared. So, you guys can see that wasn't the first thing you thought of. You didn't think to do a common denominator. You won't need to do a common denominator very often, but sometimes you do. So next time, if the answer is one big fraction and you've got multiple terms, it could be that you need to get a common denominator to make those go together. And again, that's just, it's frustrating because I can't tell you guys that you always have to do that. It just depends. If this was a free response question and it simply said find the derivative, you could have stopped way back up here. Technically, you have the derivative. But 99% of the time on a multiple choice, it's going to have some simplifying. Once in a while, you'll have to simplify with complex fractions. So, okay, does anybody have anything you would like to ask specific about question 3? Okay, then you need to move on to question 5 if you have not yet.
I don't think so. You're drawing, you're not opening it.
So we need to simplify it for this notebook assignment.
You need to simplify it till it matches the answers in the back. So sometimes that's no, sometimes that's easy, and sometimes it's a little bit more work like question 3 was. Okay. If you're still working with number 5, the second question, if you did not get its answer in the back, you couldn't figure out how to simplify that one to get what they wanted, then go ahead and follow with me. Again, if you've got it and you've checked it and you're fine with it, then please go ahead and keep on going. You don't have to listen to me if you got it right. Okay, but question 5 had to do the product rule, and it even told us in the directions anyway. But the reason why is we've got something like e to the x times something else like cosine x. Now, of course, as you guys go through this, try to use your notes less and less. You don't get the product rule or the quotient rule provided for you on the test or the AP exam. So while you're learning it, try to look at your notes less and less as you go along. Okay, so product rule says take the derivative of the first with the second left alone plus the first left alone times the derivative of the second. So to get that derivative, you have to know the product rule, you have to know the derivative of e to the x is e to the x, and you have to know the derivative of cosine is negative sine. To get to their answer, it looks like they did one step of simplifying. They saw that both of these have an e to the x, so all they did was factor out the e to the x. So a little easier to simplify. Did anybody need to ask about that question 5? Okay, let me work one more then, and then I will let you have a few more minutes. So question 7 says you need to do this with product rule, but you should realize it's product rule anyway because it's something x divided by something else, x squared plus 1. So that's how you're supposed to know moving forward that it's the quotient rule. So quotient rule says take the derivative of the numerator times the denominator left alone minus take the derivative of the denominator with the numerator left alone, and don't forget to put the whole denominator or all of it over the denominator squared. Now I know that's not what the back is going to look like because they're certainly going to simplify this. There's like terms here. You've got an x squared plus 1 minus 2x squared. So I haven't even checked in the back yet, but they're certainly going to combine these like terms. This is like 1 minus an x squared over all of that stuff. That's what I would go to. And that's what they got. So for question 7, you'll have to know the quotient rule to know the pattern to do it. I had to know how to do power rule with the derivative of x. I had to know how to do the power rule with x squared plus 1. I had to know the derivative of a constant was 0. And I guess you had to combine like terms. Anything else about number 7? Okay. Go ahead and try to do another couple questions, please. I'm going to go over question 9 now. So if you need this one, which I suspect should probably be a lot of you, the simplifying on this one may not have jumped out at you. But this has to be quotient rule. So even though it doesn't, or even though it says it in the directions, I know it because it's something divided by something. So again, feel free to do some of this out to the side, but the derivative of the square root of x is 1/2 or 1/2 square root of x. When you lower the power by 1, it moves to the denominator, times the denominator left alone minus the derivative of the denominator times the numerator left alone, all over, bless you, the denominator squared. So again, technically that's the derivative. So if you, at some point you have that correct, that means that you applied the quotient rule correctly, you took the derivative of the square root of x correctly with the power rule. It means you took the derivative of x cubed plus 1 correctly. But you could still get stuck here on the test and not realize that this is supposed to be your answer. So what algebra thing do we need to try to use to make that look better?
It's the greatest common factor. I mean, not the common denominator.
Okay, very good. So what do we normally call this type of fraction? It's a complex fraction. Notice you've got a smaller fraction. You've got a smaller fraction here within a bigger fraction. The good news is we've already reviewed simplifying complex fractions back in limits. So I told you it's going to come up more than once. So I would love to multiply this by 2 square root of x so that those cancel. But you can't do that unless you're willing to multiply everything by 2 square root of x. Now, in the back of your mind, you might be saying, that sounds like a lot of work. I don't want to do that unless I am pretty sure that's going to be right. Well, notice, as soon as I've done that, my denominator is already looking good, so I must be on the right track now. My denominator has the parts that I want. Okay, and then those canceled, left behind an x cubed plus 1. Over here, I've got a negative 3 times 2. I've got a square root of x times a square root of x times an x squared. What does all of that come out to be? X cubed, perfect. And then the only other thing they did was combine these two like terms. 1x cubed minus 6x cubed is minus 5x cubed. So I know that you can simplify complex fractions, but you have to recognize that you had smaller fractions within a bigger fraction to even know to do that. And again, this is the part that I said the first couple months of class you're going to get sick of me saying, but memorizing the quotient rule is not that hard. Power rule is not that hard. But from here to here, this is not the easiest question you've ever done, but not because of the calculus. It's because of the algebra. The random algebra skill they just decided to make you do in this question. So. Okay, does anybody have follow-up to number 9? Okay. Again, I want to offer as much help here without rushing you. Does anybody need more time to try question 11? Has anyone not done question 11 yet? Okay, I'm going to go ahead and go over it then, if it helps. Now, obviously, if you did get stuck and you're missing it, you can't figure out what you're doing wrong, please make sure you're following along with me here. Whatever the mistake was, it's going to just keep coming up on later questions. So the sooner you iron out that problem, the sooner it's going to go smoothly for you. Okay, so this guy has to be quotient rule again, something divided by something, and I want the derivative. So derivative of the top times the bottom left alone looks like this. Then minus the derivative of the bottom times the top left alone looks like that. And then you put the whole thing over the denominator squared, which looks like this. Technically, this is the derivative, So if this was a free response question and it said find the derivative, technically that's the derivative. You're welcome to quit. But as a multiple choice question, they're probably going to simplify it. So that could be complex fractions. It could be combining like terms. It could be common denominators. We've already seen several different algebra things show up in just a couple of questions. But for this one, it looks like you could factor out an e to the x. Both of these have an e to the x. And then that e to the x could cancel out one of those e to the x's, and that's where they get the answer to look like that. Okay, everybody okay with that one too? Okay, I'll give you a little bit more time now.
I was waiting for you to do 13, because I don't understand what's really asking.
It wants you to find the derivative. So that's probably going to be product rule or quotient rule, since that's our topic today. So you need to do that first. And then second, if you look at the directions there, it wants you to plug in c into the derivative. So once you get the derivative, plug in 0 into the derivative to get a numerical answer.
Okay,
But the first part is still product rule or quotient rule. So
So, for this one in the notes, why wouldn't we do quotient rule?
you can if you want to.
Oh, okay.
But that's a lot of work to do quotient rule for that. The fact that this is just a constant, that's why you don't have to do quotient rule.
Okay.
But if you did do quotient rule, because the derivative of a constant is 0, most of the quotient rule just goes to 0. You'd get the same answer either way.
Okay. Thank you.
It's only if it's like something with the variable over something with the variable do you have to do quotient rule. If
Okay.
one of them's a constant, you don't have to do all that. Okay, I'm gonna look at one more with you guys up on the board, question 13, and partly I want to emphasize something else on it. So on question 13, I'm guessing that most of you guys did the product rule. Is that how you did that one? Because you've got the x cubed plus 4x times the 3x squared plus 2x minus 5 because of that multiplication. Okay, you can use product rule there. Now I'm not telling you that what I did is easier, but just so you know, anytime you can do some basic algebra before calculus, such as question number 13, I just decided to distribute all this together. I just FOILed all this stuff out together like you did in algebra class. Why do you think I did that before? I still haven't done any calculus. Why do you think I think that might have been easier on this question?
Now you just sub in 0 for everything. You see that you got 0.
Well, I need to sub in 0 into the derivative, but I don't even have the derivative yet. I haven't done any calculus.
Find the derivative that, like, FOIL that fix.
Because if you FOIL it before, you won't have to apply the product rule. You can just like go ahead and divide each one and each one, and it's easier.
Right, so most of the time, it's not that product rule is that difficult, and it's not that you ever don't have to do it. But if you're willing to distribute all of this, or FOIL it, it's not really FOIL, but if you FOIL all this together, just notice how much easier the derivatives are. You do power rule once, twice, 3 times, 4 times, 5 times. The calculus part's a lot easier if you're willing to multiply and do the algebra beforehand. Now notice when you check in the back, they wrote the answers both ways. They wrote the answers how it would look if you did product rule, and they wrote the answer like this if you did distributing before the calculus. And then if I plug 0 into all of this, all that goes to 0, and you should end up with negative 20. So I'm not telling you you have to do it one way or the other. I'm just showing you that sometimes, especially if the calculus seems like it's going to be difficult or messy, if you can do something like distribute first, you might want to distribute first. Just keep that in mind. Okay, we've got about 11 minutes, so let me tell you where you need to be next time, and you're welcome to keep on going, but we went through question 13 together. So I'm going to ask that you do at least 5 more of these. So that would be 15, 17, 19, 21, and 23. I need you to work through at least question 23 before I see you next Tuesday. If this is extremely difficult to you, as always, you should probably try to do a little bit more. You should try to be a couple steps ahead of everybody else in class. And like yesterday's assignment, if there's any of these you need help with, every one of these have been worked out on the website. So if you need help with any of those 5, then please watch my videos. I'm not going to take class time out to go over those when you have those available. I will give you more class time to work on the book assignment next time. But at the very minimum, you need to have worked through question 23 and feel pretty good about those questions. Okay, and so again, you got about 10 minutes here, so feel free to keep working on that. Those of you that kept working at your pace, I guess a couple of you might not even have homework yet, but I will ask you to do the rest of it at some point. Alright, I know which puzzle I showed you guys yesterday because it was just yesterday. So it looks like you are on number 8. So if you'd like to do the daily puzzles, today's is up on the board. Of course, if y'all find any math questions while you're here and you want to ask me, then please go ahead. I need to go grab something from the workroom for just a second, but I'll be right back.
reminder, I do need these book pages back. These are not yours to keep. You can put them on this pile on your way out.
Here, you can't cancel those out. If this stuff is being added, there's something else. Like, if I show you the numbers. This is supposed to be 4/3, but you're trying to cancel those out and say that it's 1. You can do, you could put this over this, plus this over this, that goes your 4/3, but you can't cancel out terms like that. Anybody figured out the puzzle?
042.
That might be right, I don't know. If it's not right, it's very close. What'd you guess? 042. That's right. 042. I shared the explanation on Google Classroom if you want to watch the video. You guys gonna do anything fun for your Fun Friday?
Make cookies.
And an advisory period?
No, I made cookies for
Oh, okay. Why?
It's Cookie Friday.
You put creatine in your cookies?
I'll ask Jonas if he would bring up creatine today. He said probably, but no. No. Should, that's a good idea. He might mess with the properties.
Y'all must have had a long week. Y'all dead tired.